Okay, we're going to talk about gravity. So we did not discuss gravity much in class, but it is on the final, so I want to go ahead and discuss it with you now. It's very, very similar to Coulomb's law, which we did discuss at length in class. In fact, it's exactly the same as Coulomb's law, but instead of with charged objects, we're looking at gravity. Okay, so if you don't remember, Coulomb's law said that the electrical force between two charged objects was, there's Coulomb's constant, okay, in there, and you multiply the charge of the first object times the charge of the second object, and that is going to be divided by the distance between the two objects squared. All right, and what we talked about was as we increase the charge of one, we're going to have more force. If we increase the charge of the other one, we're going to get even more force. And as the distance increases, so as they get further away from each other, your force is going to decrease. And I used the example of the balloon that I rubbed and I held it over the little paper bits. And if I held the balloon way far away, the paper bits didn't have enough force to jump up to the balloon, okay? But if I decreased the distance, if I brought the balloon closer, then there was enough force to cause the paper bits to jump up. And if I rubbed the balloon more, then I got more of a charge, and that also increased the force. Well, this relationship is exactly the same as with gravity. It looks a little different. Instead of a K, we have a G. And instead of charges, we have masses between two different objects, all right? So let's say these are planets, all right? If this is a planet, and we'll just say this planet is 5 kilograms, and this planet is 5 kilograms, and the planets are close together, they're going to have a lot of gravitational force between them, just like your charged objects. The closer they got, the more the force got. Here's the same two planets, but now they're further away, so they have less gravitational force. Another thing that increases the gravitational force is the mass. So the larger the mass, the more the gravitational force, just like the more charge. Okay, so as we increase the mass, we increase the force, the gravitational force, and as we increase or decrease the distance between the two objects, we increase the gravitational force. If you need more explanation on this, feel free to ask, but I'm going to go ahead and go through these questions. In the formula, force, and we could call this the force of gravity, F sub g, equals g, which is another constant, times m1, which is the mass of the first object, times m2, which is the mass of the second object, divided by the distance between those two objects squared. What happens to the force if one of the masses is doubled? If I double this mass, the first mass, then I'm going to double the force. Okay, so it's going to double. What happens to the force if one of the masses is tripled? So if I triple the mass, I'm going to triple the force. Okay, if I were to double both masses on this one, let's see if that's on there. Well, it's not, but if I were to double both masses, 2 times 2, I would quadruple. I would be have 4 times the amount of force. This one says if we quadruple the mass, one of the masses, once again, quadruple is 4 times, so we would quadruple the force. Okay. Which two objects have the greatest gravitational force? Well, I said the two that were closest together are going to have the most force. These two are close together, so we're going to have more force. Just like the static electricity with the balloon and the paper bits being the closer I brought it down, the more force there was. It's the exact same relationship with gravity.